Classification of dye materials. Dye is defined as the positive reproduction of the form of the prepared tooth in any suitable substance according to GPT-9. According to Anisawa's 11th edition, it is reproduction of a prepared tooth made from a gypsum product, epoxy resin, a metal, or a refractory material. It is also defined as the dye is the model of the individual prepared tooth on which the margins of the wax patterns are finished according to Schillingberg. Classification. It is classified as non-metallic dye material, gypsum products, silicophosphate, cement, refractory dye materials, metallic dye materials, which include electroform dyes, amalgam, metal sprayed dyes, polymeric dye materials, which include flexible dye material, epoxy resin, and also CAD-CAM materials. Gypsum products. Gypsum products are available in 5 forms, from type 1 to 5. Type 1 impression plaster, type 2 model plaster, type 3 dental stone, type 4 dental stone with high strength, and type 5 dental stone with high strength and high expansion. Electroplated dyes. Metal dyes can be made by copper or silver plating. Copper plating. Copper-plated dyes compound or addition silicon rubber impressions. The surface of the impression material is treated so that it conducts electrically. This process is referred to as metallizing. Composition: copper sulfate, sulfuric acid, and phenol sulfonic acid. Silver plating. Indicated for polysulfide, polyether, and silicon rubber impression materials. Composition: silver cyanide, potassium cyanide, potassium carbonate, and distilled water. Metal sprayed dyes. Bismuth alloy with fusing point of 136 degree Fahrenheit is melted at 145 degree Fahrenheit. Dyes poured and solidify at 30 pounds of pressure. Advantage: rapidly from the elastomeric impression materials, and the disadvantage is that alloy is soft and care is needed to prevent abrasion of the dye. Amalgam dyes. Material of choice previously largely replaced by electroplated dyes. Resistant to abrasion. Procedure: it is made by packing amalgam into impression made of impression compound. Advantages: it is having a superior strength, resistance to abrasion, and reproduce fine details and sharp margins. Silicophosphate cement. Similar to the filling and cementing material. Composition: the powder is a mixture of silicate powder and zinc oxide liquid contains phosphoric acid. Epoxy resin. Used with polyether, polysulfide, or silicon. Hartner polyamine causes polymerization, which is toxic. Composition: epoxy resins, polyester, and epiamines or polymeric material with fillers, either metallic or ceramic fillers. Flexible dye materials. Similar to heavy-bodied silicon or polyether impression material, it is used to make provisional restoration, entire composite resin inlays or onlays chair side. Advantage: it is having more rapid setting 10 minutes, ease of removal of provisional restoration. Polyvinyl dye. Irreversible hydrocolloid impression filled with the fast setting medium, viscosity polyvinyl impression material. Polyvinyl cast into the preoperative mold. The polyvinyl cast is flexed to remove tooth-colored resin from the undercuts. Interim restoration on the prepared tooth. Polyurethane. Polyurethane is the most accurate, strongest, and cleanest dye material than dye stone and epoxy. Silicon impression materials can be used. Base and Hartner. Properties: no noticeable shrinkage or expansion, more accurate than epoxy, water resistant, superior mechanical properties, approximately 94.82 megapascal. Ceramic dye materials. Recent advance in dye materials, porcelain inlays, onlays, and veneers. Manipulation: supplied as powder and liquid system, mixed into paste and vibrated into the impression and allowed to set for an hour. after which the material is removed and fired at 600 degrees Celsius for 8 minutes to produce a strong dye. CAD-CAM dye material systems, which uses CEREC, the E4D or D4D Tech, DCS Precedent System, Iterio, and Lava.